Okay, so that's it for the board features. So we can get rid of this boring bar. Now I think we'll drill the mounting holes in the top. Then I can do a trial fit on the rifle. Make sure I got enough clearance for the scope. Okay, let's see here. Only problem with WD-40 is it makes a mess. Okay, need some deburring here. Okay, so some more burrs to take care of on the parts we bored. Now, make sure we put these holes in proper position. I guess it doesn't matter. They go either way. So let's center up on the x-axis. And then figure up on this surface for y. Okay, the holes are 152 thousandths in. And centered on X. And the diameter is 166 through. I think it's 28. Nope, 19. Number 19 drill. And then they are 8/66 apart. Okay, now they need to be counterbored 1/4 inch diameter. And the depth is a little tricky because we're working off an angled surface. So I think I'm going to work off the bottom of the part. And I'm going to use a 1/4 inch end mill for the counterboard. Okay, so I'm going to have to touch the end mill to this parallel. Right there, and figure out how far to drop the table down. Okay, so there was no easy way to get the depth of that counterbore from the drawing. You can see I had it listed at 62 thousandths deep from the top of this radius here, but working back is going to take a lot of trig, a lot more effort than I'm willing to put in on a Sunday night, so I went back to the CAD system, redimensioned it from this 1" 60 reference surface here, the points down here. Okay, so 162 thousandths up from that parallel that we touched on. So that means I got to drop the table down 162. right there. Okay, so that's the depth of our counter bore. That's the nice thing about CAD. It saves you a lot of calculating on when you're making the part. Here's one. Looks reasonable. Okay, now we got two mounting holes, counterboard, so we can mount these things on the rifle now and mount the scope in it and make sure everything works right. Let's go ahead and do that. Okay, so let's see if these scope mounts fit. The holes in the receiver were number 840, so I bought these special screws. They're Torx screws and they're 840 and they're just for mounting scope rings. I didn't want to use the same screws for the clamp ring because they're fine thread, and being made out of aluminum, I'd rather use a coarse thread for greater pull-out strength. So I'm just using ordinary socket head cap screws for the clamp ring. I might get, these are stainless I've got here, I might get black ones just so it looks better. Yep, so far so good. Yeah, the front of the objective clears the barrel, that's a good sign. Nice snug fit in the bore. All the holes line up. Must have done something right. Alright, looks like a success. Guess you can see that. So they're not pretty, but they're functional. So the next thing we have to do is finish shaping them. I think we'll probably finish up this lower part here. Got to mill this width to where is it? 600 thousandths down into the where was that? 336 diameter hole. Mill down into that, and then we mill these 35-degree cuts tangent to that radius, and that'll finish the bottom part. And the top part's easy. It's just two 35-degree cuts. So let's get going on that, and we'll finish this project up. Then I'll have to break out the anodizing bench and make it black. Okay, so we're going to mill this width on the bottom part of the lower base ring, and that width of that thing is 600 thousandths. So I'm going to find the center of the part with my edge finder, and then move 300 each way plus half the diameter of whichever end mill I use. So let's go ahead and do that. There's halfway. Now I'm going to use a 1/2 inch end mill. So I have to move half of the 600, which is 300, plus half the end mill, which is 250. So I got to move 550 each side. Start out at 560 and leave a little extra stock. Depth is not critical, just needs to get down into that bored hole. See, one other thing I'm going to do before I make this cut. It always makes me a little nervous putting two pieces in a vise like this, because if they're at all different in width, one of them can move. So what I like to do is just put a couple strips of paper between the movable jaw and the parts, just to even out the force. Make it less likely for one of them to slip. We'll go down to about halfway to the center of the bore and hit the cut. Alright, now I can go into 550, take finish cut, I'll be done with this side. Okay. And now we'll do the same thing on the other side. Alright, that finishes that part. Now we have to take them out and set up that 35-degree angle. Next we'll set up and we'll cut these two 35-degree angles tangent to the bores. So let me get that set up. Okay, so I've come up with a setup to mill these two 35-degree angles on this base ring. And I could just use a protractor. It's really just for looks. It's an aesthetic cut, but I thought it might be more fun to use a sine bar and also a little more repeatable. It's a lot more risk of error in setting up a protractor than there is setting a part on a sine bar. So let's go ahead and do the sine bar. I know I haven't done a instructional video on using sine bars yet, so I'll kind of go over it a little bit, but eventually I want to do a video on how to use these things. Well, sine bar is based on trig. Basically, a sine bar, the distance between the two rolls, represents the hypotenuse of a right triangle. So if you remember anything at all about trig, if you know any two parts of a right triangle, you can find the third part using formula. So for a sine bar, I want to move this sine bar up 35 degrees. So to do that, I have to know how big of a stack of gauge blocks to put under this far roller. So to figure that out, I take the sine of the angle, which is 35 degrees. So the sine of an angle times the hypotenuse, which in this case is 2.5 inches. So the sine of 35 times 2.5 tells me how big of a stack of gauge blocks I need to put under this far roller to get a 35-degree angle. Okay, that's pretty much it in a nutshell. If you don't know how to ring gauge blocks together, how to build a stack of gauge blocks, I do have a video on that, so you might want to check through the YouTube channel and find that video and enlighten yourself or refresh your memory. So let's go ahead and set this sine bar in here. I got a little rare earth magnet down there to push the sine bar against so it doesn't move on me. Because obviously if the sine bar moves, it's going to change the location of the cut we take on the part. So we want the sine bar to be in the same place every time. And along that same order, I put my stop against this center cut on the bottom here. So we just rest the part against the stop on the sine bar, and it should be pretty repeatable. And again, I always like to block up the far side of the vise just to keep the jaw from tipping, so I'll take the other part and put it back here just to support this end of the vise jaw. So now make sure the part's in there nice and straight, not rocking around or anything. Snug the jaws up and we're all set. So now, how do we find out where to take our cut? Well, we can. There's a couple ways to do it. In the old days when I could see, I would take a magic marker or a Sharpie and darken this radius inside, because we have to mill a cut tangent to that radius, and then just sneak up on it until it touched the magic marker. But I can't see very well anymore, so what I can do now is just put this 3/36 diameter pin in here, and I'll locate the end mill off the pin, both vertically and in the x-axis. Then we can tell exactly where we need to go to mill tangent to that bore. So let's go ahead and set that up. Okay, obviously I don't want to touch the hardened steel pin with my cutter, so I'll use a piece of paper under it. Set my stop and then just bring the table up till the paper drags. Okay, then the paper is about 3/1000 or 4/1000 thick, so I'm going to move 4/1000 more and we'll be right there. Okay, so end mill set in the Z direction. Now let's pick up the side of it here. I'm going to have to crank up a couple turns so I can touch the side of the pin. I'll just sneak up on it, same way as I did on the Z-axis, till the paper drags. And I'll set my dial or my DRO to 0. Get the cutter out of the way, move over 4 thousandths. And we're good there. Okay, now I want to mill tangent to this bore, which is the other side of the pin, so I'm going to move over another 336 thousandths. I'll do that and reset my dial to 0. Alright, that's my goal. Okay, that's where I want to go. And also, I want to set, let's go back up to the top of the pin where we started. I want to go down half the diameter of the pin in the Z direction, so half of 336 is 168. 168. Okay, now we can take the pin out. I think we can take the pin out. Now if I just take some cuts until X reads 0, we'll be done. Not taking very heavy cuts because it's not a real sturdy setup. I don't want to move the part. So I just take light cuts till we get to 0, and flip it over and do the other side. Okay, we're at 15. I'm going to start sneaking up on it a little bit at a time. I don't want to go too far. In case we measured a little bit wrong, I'd rather stop a little short than have a step that will go a couple thousandths at a time. Still not quite tangent. A little bit of step yet. A couple more thousandths. Yeah, that's perfect. Can't feel a thing there. Well, that's one side. So now we should be able to carefully remove the part. Take the burrs off. And just flip it over. Alright, we'll do it all again. Machining is all about setups. If you come up with efficient setups, you'll be a good machinist. setups suck, your machining's going to suck. So you have to be pretty creative at times. I've had projects where I've spent an entire day making a setup, machine one part, because it's so complex. But that's all part of machining. Almost exactly what the other side was. They're just cleaning up now. It's within 1,000th of an inch, so it's pretty good setup. Yep. Can't feel a thing. It's nice, perfectly tangent cut. Okay, it looks similar to what was on the drawing. All right, now I'll go ahead and do the other side, and I'll think about how to make this last cut, and then we got to go back and also make a cut in here, a cut down planar with this face, and then down to like a 5-degree sloped angle. Not sure how I'm going to do that yet. I'll have to think about it. So I'll go ahead and finish these up, and I'll get back with you, and we'll make those cuts.